Hi friend, this is the welded part and we check how much penetration goes inside this. So this is a pin, this is a plate 16 mm and this is a pin 6 mm. Here welding done, you see here, and how much penetration goes inside this both plate we calculated here. So this is a sulfuric acid, pour on these parts and check with a microscope. So this is a sulfuric acid. We put sulfuric acid 1:10. That means sulfuric acid plus water ratio having 1:10. That means sulfuric acid is 1 part, and then water is a 10 part of that. So we use here. Hi friends, you show my videos. I am using words sulfuric acid and water to check a welded penetrations. Welded part to check penetration, how much penetration goes inside that particular part. So we use in this video sulfuric acid H2SO4 plus water H2O, and this ratio we use in these videos to check penetration in welded part 1:10 ratio. Okay, that means 1 part of sulfuric acid we use 10 part of H2O. Friends, you notice here friends, in sulfuric acid we put water. You again notice here in sulfuric acid, if you add water, then water having less density as compared to this. So water, this is a sulfuric acid, and we put H2O, then this H2O is upper surface of rested on this upper surface of this sulfuric acid H2SO4. So what means? That means this is a low specification and this is a higher specification. So this water is not go inside this. Only here top surface is get a reaction, and this reaction is get exothermic type of reaction. So friends, we put a better reaction. So first of all, in water H2O we put H2SO4. First of all, we take water, then use H2SO4, not H2SO4 water is used. So here two different things, because this is a lower specification and this is a higher specification. Then this H2SO4 go inside this water and get a better reaction, as type of this reaction is a exothermic reaction. That means this is a two welded part, and if we cut here and put this H2SO4 in H2O, then this is a get a better reaction as a exothermic. This is exothermic means heating up, that is the get exerted energy, that is the exothermic. Exothermic means exerted energy, and endothermic means it consume energy. Here energy is released. So in this type of exothermic, all these foreign particles is removed out. So you used 1:10 ratio H2SO4 as well water. Friends, one more question is here, how we use water in sulfuric acid. Friend, this is a not only acid, this is a strong acid. This is a strong acid. So dilution of this sulfuric acid, we use water to dilute them. Okay, now we move here friends. This is a scale to measure a pH value. This is a 7, 0 to 14. This is a scale, and this shown 7. That means that this is a neutral, and if goes in this direction, that means acidic is more strong. Acid is having more stronger, and if we move in this direction, then base is more strong. So this is a strong acid, that means H2SO4 having very less value. So dilute, for this we use water. So friends, you know water is a neutral, pure water is a neutral, and it having pH value what? 7. What is pH? P means power, H means hydrogen. This terminology used to what? Because of this scale is a logarithmic, so you use pH scale. This is a pH scale. Okay, power of hydrogen, this is a power of hydrogen, pH means. Okay, now pH formula equals to what? Minus log 10 base hydrogen ion concentration. Okay, or another one, minus log hydrogen ion concentration, because 10 is already here. Okay, so friends, you know pH value of water, pure water is 7, then minus log hydrogen ion concentration. And if we find out hydrogen ion concentration, then what? 10 is to minus 7, 10 is to power minus 7. This is a hydrogen ion concentration we find out. So this is a ratio 1:10 to use to check welding penetration. Friends, one more thing is, when sulfuric acid is used in water, then how can we get a clear picture? Because of exothermic. So what is the reaction between them? If we add H2SO4 in H2O, then exothermic reaction is happen, and we get what? Hydronium ion plus SO4, 2 negative ions. Okay, and if you balance this equation here, friend, 3 hydrogen, but here 2 and 2, 4 hydrogen. So we multiply here, then it will become 4 to 6, total 6 hydrogen, and here we multiply also 2, then this is a 6 we get here. So here equation is balanced. So friends, this is all about penetration. How can we get a clear picture? Because of this exothermic reaction. And what is pH value you calculated? Hydrogen ion, so many things. So I hope you enjoy this videos. Thank you friends.